Okay, 3, 2, 1. Okay, what's up, everybody? Call me Tess. This is an optimization problem from the practice exams that we get in the math department offices. I had Professor Valencia, spring 2018. I did the practice exam finals questions as much as I could, and you're actually looking at a prepared sheet of questions that I have from the actual practice exam final. I went through all of these and I did all the work necessary to solve them because I wanted people who took calculus afterward to benefit from my work. I felt that it was important, especially that calculus is a class that's needed for a lot of majors. So, I wanted to help others out. I had a hard time in calculus, and from spring 2018 to spring 2019, I went from Calculus 1 to Calculus 3 and analysis afterwards. And I'm about 2 classes away from the math major. So, I'm excited for that. And yeah, I just want to help you guys out in some way. So this is optimization. And what optimization is part of calculus where we want to figure out how to maximize or minimize something, anything. Um, Integrals and infinite sums are other parts of calculus along with derivatives. And these things you may not understand now, but if you go further into math, you'll understand it later. Uh, the important thing is right now is that this problem will help you to solve other math problems or other calculus questions because of all the things that are used within it. You have critical points, you have, area, you have sums, you have conditional statements, a lot of different things, and learning that, if you have an x and a y and you go into multivariable calculus, you'll be able to solve this problem fairly easily. Uh, if you use a lambda and things of that nature, but let's just stick to optimization as we know it now. I actually like optimization problems. That's why I chose this one. I recorded this before and I messed up, so this is my second attempt, and this is just to test Easy Taught software. I really like this platform. I like using it, and let's just get into it. I don't want to hold up too much of you guys' time. So uh, a rectangular poster is to have an area of 100 square inches with a 1-inch margin on the right and left sides, and a 2-inch margin at the top and bottom. Find the dimensions of the poster with the largest printed area. So there's stuff that we know in there, and we could go off of what we have here, but I'm going to use this as a reference, and I'm going to use my whiteboard as a main tool for doing this problem. Firstly, we're going to draw a diagram. So that's probably the most important part of this, and let's just get started. Let's go into this. One second here. All right, so we got our diagram. Move this up the way. And I'll also keep my palette right down here. So now, if we look and we say that we want a diagram of, let's say, a square sheet, right? We want to maximize the area of this poster. Let's say the poster is like that. Matter of fact, the poster would probably look more so like this. And on the outside, it has 1-inch margins and then 2-inch margins at the top. And that's where I messed up on previously. I mislabeled what I was doing. So let me go back and let me check my information and make sure. So yes, so we have 1 inch margins on the left sides, 2 inch margins on the top. So let's go back to the whiteboard really fast. All right, 1 inch margins on the sides and 2 inch margins on the top. If we have this information now, we're able to find out certain things about the given equation. So we have an area, and we know that area is equal to x times y. And we're able to find out that 100 is equal to x times y, which is also the area. So using that information, we could find out that if we took an x and we multiplied it or divided it by both sides, we get that is 100 over x, which is equal to a y. So if we have that and we know y is equal to that, we're going to go ahead and use the constraints that we know. What are the constraints? The constraints are the given conditions within a problem. You'll see other optimization problems. Let's say, for example, you wanted to find like a fence. You wanted to build a fence, and you have this x, and then you have these y's over here. And we know we wanted to find the area of this little fencing part. We know that area is equal to x times y. But within our given constraints, it'll be 2y plus x is equal to a given area. And those are just constraints. So if you looked at the problem and you've seen the way that it is now, we want to use those inches at the top and the bottom and on the left and the right sides as our given constraints. If you're able to get this little trait down on how to figure out a given constraint, you're able to go about the problem in its best fashion. It's even hard for me, and I know that when I have to return back to optimization, I often have to do a few problems, and that takes me at least like 20 minutes, 30 minutes sometimes. It took me as long as 40 minutes just like making this video originally did. And let's look at these given constraints that we have. If I go across and I look at the ones right here, and we're maximizing this area, you could easily see that x plus 2 is our given constraint because there's a 1 here and a 1 here, right? Those are our given constraints. Now, take a guess if I want the span of the y-axis. What would be our given constraints right here? If you said that our given constraints would be y plus 4, you're absolutely right. These are our given constraints in the problem for a simple reason. It's that we want these margins. We want our things to have these given margins. And what optimization does is that if you're able to put in any value for that x in the equation that I just wrote, which I'm going to read right now, if you're able to put in any values, you'll be able to be at its maximum format at any given point. They use this a lot in photography and like posters. We're making posters like editing, photo editing. Uh, you'll have to know this. The computer takes care of a lot of it, but if there's ever a point where you had to do it by hand, you could at least say that, oh, I know how to optimize that, because I learned that in class. You won't specifically remember it, completely like I do, but some people are gifted that they remember it and they're able to execute it with flawlessly. I'm not. I have to return back to the problems. Um, I know that working with the problems for me is just the best way of just going about it. I just do problem after problem after problem. It just works for me. So that was our given equation. And now with our given equation within these given constraints, we could solve our problem. Now, we'll come back to this and we'll use this for now. This guy in red here. So let's use this guy. If we know y, we could plug y into our equation, right? If we plug in y to our equation, let's solve, or matter of fact, it wouldn't even be solving, it would be simplifying. Let's simplify our equation here. So I'll just indicate that. And we use the FOIL method. So I'm going to write FOIL on the outside over here, just so we know we're going to FOIL it. If you guys don't remember FOIL, it's a good time to brush up now. FOIL is, a fairly easy concept. It's first out, inside last. So we're going to handle the outside expressions first, and then the inside last. Let's see, we're going to get 100 x over x plus 200 over x. Well, nope, I missed one. Sorry. So I get 4x plus 200x. Oh well, not 200x, just 200 over x plus 8. We did that by FOIL, so I'm going to show you how it looks like. We did that. We get this. We go to the next one. We did that. We get this. We go to the next one. We do this. We get that. And we do that. And we get this. I'll just take a quick look at that while I delete some of these lines. You don't want it to get too messy on each page. We'll be using multiple pages, and this solve may take a little bit, so I'll prepare you guys. We're not even close to finish yet. We have probably about another 20 minutes for this solve. So once we do the FOIL, we could simplify this by simplifying that. Let me do that first. It's going to be 100 plus 4x plus 200 plus 8. And this 8 could actually be combined with the 100 here. So that 8 and this 100 are the same. You could combine them pretty much. You could get 108 plus 4x plus a 200x. Let me make sure I did my math right. Yep. So now that we have this, we're going to go ahead and we're going to get the derivative of this. So now, before I continue, there's 3 steps that are required to solve optimization problems. You take the derivative, make sure I tell you the right thing. You take the derivative, you set it equal to 0, and you find the critical points. Before you could even get to taking the derivative, you see that there's a whole bunch of information involved in it. And if you guys have any problems with that, we could go about solving some optimization problems together. But the most important part is that you get to this part, which is where we take the derivative back. And to get here, you have to understand how to make the diagram. That's why I said, firstly, make the diagram. That is very important. I'll put a star here. and understanding it. So the margins are constraints. The area is what we want to find. Let's do our optimization, which is maximizing it. We could also, it could have been said that we minimize it, but we're looking for a maximum. If we were to minimize it, the only difference, could you guys guess what the only difference would be? That'd be the only difference. It would be minus signs instead of plus signs. So let's go ahead about getting the derivative. So I'm going to switch back to my desktop because I want to show you guys what the derivative of each one of these are. So we're here on my desktop, and I want to bring over my integral calculator. So to find the derivative of that area formula, we're going to take the derivative of 108, and you guys could guess it. That is 0 right here. You guys won't be able to use calculators on the exam, but if you guys want to save yourself some time in solving problems, you could use a derivative calculator, but it's probably best to actually do the derivatives by hand. But I'll just let the calculator do most of the work for me right now. So we're going to take the derivative of 4x, and you guys probably know this one, which is 4. And this last one is why the reason I really brought out the derivative calculator, which is going to be 200 divided by x. And you have to be careful when you're inputting things into the derivative calculator. So if I was to really be picky about how I'm inputting something, I would have inputted it like this, and that would be the proper way. If I was to add a power, I would have put inside the brackets. I would have put that inside of the brackets, but let's not go there. Let's do 200 over x, which is negative 200 over x squared. I know that because I have done this problem, and also I know my derivatives pretty well at this point. So if I was to simplify it, it doesn't get any simpler than that. Let's show the steps. So if we clicked on this or we show this, we could see that this problem is actually a constant over 1 over x, or the derivative of 1 over x. We could pull the constant to the outside, which is this guy right here. So forget about him for now. But this is probably the part that is most confusing if you looked at a derivative calculator. If you understand the concept that the x on the bottom, or x to the negative 1 power, is displayed as 1 over x, then you'll be able to figure out the derivative very easily. So let me show you how it looks like really fast for those that didn't catch it. So I'm going to use a new whiteboard, and this is strictly going to be for my derivatives over here. So my derivative was a positive 200 over s. I want the derivative of that. This is definitely not the way that you want to write properly your derivatives, but I'm just picking up where the calculator left off. So you guys understand the concept that this is 1 over x, but we still need to find the derivative. We just pulled out a constant. That's it. This is a constant. It's the only thing that we've done so far. Now, if we carry the constant down, we're going to say that this is x to the negative 1 power, which you guys probably learned at this point. If I say that this is x to the negative 1 power and I want to find the derivative, this little line right here indicates that I want the derivative of that. If I take the derivative of that, and we already know that it's nx to the n minus 1 power, which is power rule. If we take the power rule of this thing right here, that's a bad circle. You take the derivative of this thing right here. That'll mean that is negative 1x. A negative 1 minus 1 is a negative 2. And that's our derivative right there. We times that by 200. We get negative 200. That's squared, which can also be written as negative 200 times, times 1 over x squared. So negative 200 times h to the negative 2 squared is also written as negative 200 times 1 over h squared, which can also be written as negative 200 over h squared. Hopefully that makes sense. If not, we could go back to the calculator, but for now, we're just going to continue on with the rest of our problems. And 1 second here, I'm just going to delete this page. So take a quick snapshot, or you can pause it right here. Once we get to the actual solve of our derivative, we get that this is a 0. I'll put a line through it. All right. I don't even want to do that. I want you guys to see. That's a 0. The 4 brings down, and it's the derivative of 4x is a 4. And then we get a negative 200 over h squared. All right. This is what we're going to take onto the next page, really. This thing right here. So let's take that to the next page. So a is equal to 4 times 200 over x squared. So why did I make a big deal about all of this? So you take the derivative. Now you set it equal to 0. So we set it equal to 0. And when we do set it equal to 0, let's plot this out. All right. We set it equal to 0. Excuse me. I could do this multiple ways. The easiest way is to first multiply everything by 4x squared. To get rid of that 4x on the bottom of that equation right there in the middle. And 0 times x squared is still going to be 0. So we'll leave it at 0. So we got rid of that x squared on the bottom. That's this guy. And we multiplied it by x squared, and you see the x squared. And that was 0. All right. So now we could move that 200 to the other side. So we'll get 4x squared equals 200. Right? And how you may be questioning and going like, how does he know how to do this? And it's just, these are just simple steps to help you solve a problem. So imagine you're a detective or a problem solver. So you look for available routes to solve the problem. You could have moved the 4 to the other side. It would have been a lot harder than just doing what we did now. So let's continue on. Now I want to take this 4 and I want to move it to the other side. So I divide both sides by 4, and I get x squared is equal to, I believe it's 50. If I take the square root of that, I get x is equal to the square root of 50. Right? And once I'm able to get that, I don't know if you guys remember how to do the simplification of radicals, but you could also say that this is 25 and 2 which x is equal to 5 radical 2. That part is probably very tricky, but x is equal to 5 radical 2, and that was all from what we knew before. So this is one of our critical points. So we have part 1 of part 3. The last part is just finding y. We already know that. So now, give me 1 second here. So now I want to be able to take this x that's right here, and I want to put that into our y equation that's here, now that we have a critical point. So I'm going to do that now. Our y equation is the following. Well, let me actually remind you guys of what the y equation was. So we have that. All right, that's our y equation. And now with our given information, we can rewrite this as, because we now know the critical point. Now we could solve for y by simplifying. 5 into 100 is 50 over square root of 2. Right? Well, I'm sorry. I did wrong math. We all make mistakes. So that's 20 divided by the square root of 2. And to get rid of the square root of the bottom, because we can't have that as the answer, we square everything. So just imagine I go to square everything now, right? And I say that this is y squared equal to 20 times 20 is, I just want to make, I don't want to make any mistakes for you guys. So I want to find the square root. I'm just going to do a quick calculation on the computer really fast. All right, that's 400. Don't want to make any mistakes for you guys. So it's 400 over 2, because if this was the square root, remember that you'll take a 20, you go radicals 2, going to be 20 radical 2, and you just multiply across. It's just simple multiplication. And this would be equal to 400 over 2 would be equal to 200. And remember, that's y squared, so y squared is equal to 200, because we have to square both sides. And now, if we take the square root of both sides, we get y is equal to 200, or square root 200, which actually simplifies to 102. And if we did the math, we take the square root of 100, we get 10. We get 10 square root 2. And that's our critical point for y. Once we have both critical points, we're able to see that this is the equation that needed to be solved. So remember, there's a few things that you need to do for optimization, but if you're able to remember to draw a diagram first, you're not able to solve, you won't be able to fully solve an optimization problem without visualizing it first. So that's important. So first, draw your diagram. Next, use the given information to solve the problem. So let's say I go back. Let me show you guys my screen, matter of fact. Remember, my answers are the following. 5 radical 2 for x, and y is 10 radical 2. If we use the given information, we're able to find a few different things out. Let me go to my desktop. So you have your area, which we found. X and Y is equal to 100, and we're able to identify Y is equal to 100 over X. We used our constraints. These are known as our constraints. This is very important, that concept of a constraint. We were able to use what we know for Y to put it inside of our constraint to solve for a given X. Once we have our given X with all this math that we did, understanding the concept of derivatives and power rule, we're able to drill down until we find that S is equal to radical 50 or S is equal to 5 radical 2. We have that S, we could put it into our Y now. Once we're able to do that, you could go ahead and verify what Y is, and we are able to get to radical 200. Square root of 200, and that's equal to 10 radical 2. And I'll show you that this is true. So let me pull out the calculator. Remember I said I was going to pull it out before to do some math. I want to make sure that, I didn't get anything wrong for you guys. So we have which one did I solve? 5 times the square root of 2, which is equal to that, times, because remember it's length times width, times 10 radical 2, which is equal to 100. So through what we were given, we optimized the point that was it's at its most optimum point within a given constraint, which is 10 radical 2 and 5 radical 2. Within those given constraints that we have, those 2 points, those critical points, are where the area is maximized at. So for the given X and the given Y. I have more than enough time to go over some other things with you guys, but I don't know if you guys heard of Brilliant before, but Brilliant is a website where you could learn. I'm not sponsored by Brilliant. Let me not sound like that. But Brilliant is a website that you can learn about calculus as well. I was looking at some of the things that they were doing. Let me go to the Brilliant website. I think I'm signed in. But I believe that they have a calculus course on here. And I was looking at it today. See if I can find the course for you guys, but I can't seem to find it. If you go to the Brilliant website, you type in calculus in a nutshell, you're able to find some information that probably benefits you for the course. I mean, to sit down and dedicate, an hour or two to outside work is a lot, but it's worth it at the end. Some people not to, some people choose to. Whatever works for you is usually the best way to go. I feel that Brilliant is a good website. If you're able to spend some time on the Brilliant website, you can see that, what optimization does. So in this given equation, a soccer player makes a breakaway. So just imagine that there's a soccer player, they run up a straight field. There's 2 lines of sight for each of the goalposts. So that's the triangle right there. And it forms an angle right here. They want to know the player has the best chance at scoring at a certain angle. Is there optimal time for her to shoot? So let's see if there is an optimal time. Just pay attention to the number and watch the diagram. So the soccer player is running up to the pitch, and there is an angle where it is optimized for this player to shoot. And I'm going to continue right there. If you look, that says 9:13, and it goes a little higher, and then it goes back down. So there's an optimum time for the player to shoot, and you'll learn in calculus how to calculate that. And optimization is one of those ways to calculate it. The explanation goes further to show that this is the graph, and you guys learn about these things in limits. And you have those tangent lines going around. You learn that at a given time, there's a place where it stops increasing and starts decreasing. That idea is known as a critical point. All right. Thank you guys. I appreciate you guys staying so long for the video. I'm done now. It's been a long time. I have my water falling on the floor. I'm a bit exhausted, but I'm happy to help you guys out. If you guys want me to go over some other problems on the sample final, let me know. I'll pick out some specific ones, or if you got some, we could do that. There's about like 18 or 19. I guarantee you in 19 days you could learn how to solve every problem on the exam. The thing is that you'll have to dedicate the time to actually doing the outside work and going over some of the ideas that may have seemed arbitrary for me to go over today. But yeah, this is Call Me Test. Thank you guys. I appreciate y'all, and I'm out.